Okay, so now let us draw the output response for the second order system to unit step input for the underdamped case. Okay, so you have drawn the axis. In the x-axis we have the time, and here it is the output response with respect to time. So yeah, the output response, it looks something like this. Okay, okay, so it looks something like this, and this is the steady state value, and this is normally, it has a value about 1. Okay, the steady state value. Now you can see that the characteristic of this oscillation, this output response, is that as time progresses, the amplitude of the oscillation keeps on decreasing. Okay, so now let us just point out some important things associated with it. Okay, so this is the steady state value, and this is the first peak value. Okay, it is the first peak value. Okay, it's a maximum value which is called as CT max. It is the maximum value of the output. Okay, now this, the time at which this occurs, is called as the peak time. This is called as peak time, the time at which the maximum value of the output occurs. Now the time instant at which the output, it reaches the value 1, okay, the steady state value at the first instant. Okay, this is the steady state value, and the time instant at which it reaches the steady state value for the first time, that is called as rise time. Okay, rise time, we'll be discussing about those things in detail. Okay, and their mathematical expression. For now, just to understand these things. Okay, the time at which the output response reaches the maximum value, it is called as the peak time. This value is called as CT max. This time at which the output response reaches the steady state value, which is normally 1, for the first time, it is called as the rise time. Now the time instant at which the output response reaches 1/2 or half of the steady state value is called as the delay time, T subscript D. Okay, and the time at which the output response reaches the steady state value and finally settles down, this is called as the settling time. There is a difference between settling time and rise time. Okay, the rise time is the time at which the output response reaches the steady state value for the first time. Okay, it reaches this point, then it again, the amplitude increases, then decreases, it gradually decreases, and finally the output, it settles down at around this point. Okay, which is the settling time. Okay, again it reaches the steady state value, which is 1. So finally, when the output response reaches the steady state value and continues to stay at that range, that is called as the settling time, TS. Okay, so here there are various things that are important. So first one is the delay time, which is the time at which the output response reaches half of the steady state value or 50% of the steady state value. Normally it is 1 we take. It can be anything, but 50% of the steady state value. Okay. Then we have the rise time, which is the time at which the output response reaches the steady state value for the first time. Then we have is the peak time. Okay, it is the time at which the output response reaches the maximum value. Okay, the maximum value. And then we have is the settling time. The settling time, where the output reaches and stays within the steady state value, okay, the range of the steady state value. So that is called as the settling time. So these are the 4 things that we'll discuss in a separate video, and we'll find out the mathematical expressions for each of the following terms. Okay, so this is the time response for a second order system, the waveform for unit step input for the underdamped case, which is very important. Okay, this is the most important case of second order system. So you remember all the things, and you please download the PDF file from by clicking the link in the description, and see the whole mathematical derivation, how we got the expression Ct is equal to 1 minus e to the power minus zeta omega nt by root over 1 minus sigma zeta square sin omega dt plus phi. Okay, so you please see that how we got the output response, that expression, and then we'll be discussing about these things in the next video. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.